Alright, you bunch of maverick renegades, we're going to do our motion notes part 1, going over distance and displacement. We talked a little bit about this at the end of class after you did vocab. We're going to go ahead and go over it formally and do some examples of how this works. Alright, so distance, first of all, distance is the total amount of length, so write that in, covered by a moving object independent of the direction of motion. So path, independent, not dependent of the shape of the path, right? So it's independent of the direction of motion. It doesn't matter what direction you're moving. So think about this as this is like in your car, this would be a speedometer. Not a speedometer, that's stupid. Like an odometer. Right? The odometer gets your mileage, right? Mileage. I'm going to go ahead and shrink this a little bit. Okay, so the odometer gets your mileage, right? And it's like in Ferris Bueller's Day Off when they're like, oh, my dad's going to know if I took the car out for a ride. And then Ferris is like, we'll just drive backwards. And that, of course, doesn't work because you would still be adding on mileage, right? Okay, so since we don't care about the direction we're going, this would make distance a scalar quantity, right? Scalar quantity. Okay, this is a magnitude or a number without direction. So without direction. Or what? Magnitude without direction. Okay? Displacement, on the other hand, is the distance measured in a straight line or linear distance in a specified direction, so in a direction. This is also called, to me, the net change in position. Remember, this triangle thing means change in. So the net change in position, so how far you were actually displaced. And think about that, the water in a beaker being displaced when you drop some crap in there. So that's the net change or the displacement from the position. Okay, this is a vector quantity. Think vector is kind of like, I'm going to go ahead and just say vectors mean arrows. It's an arrow. So an arrow points in the direction, right? In a direction. So if you care about the direction, it is an arrow, right? And that's a vector quantity. Okay, this does depend on the path. Okay, so let's look at this little picture of a map we got right here. So we got like the Goof Troop map here. You're going around in like squiggly lines and all that. Going on all this big old path. It doesn't matter if all of this right here was 600 meters. It wouldn't matter. If we are looking at just the displacement, it's a straight line from point A to point B, the finish, right? Okay. So even if I did all these squiggly things and my distance came out to 600 meters, right, so this would be my distance. This is the total length of my path. Or even if I go backwards at some point, right? My displacement, on the other hand, would just be the straight line. So let's say that if this were 600 meters and this were only 100 meters, it wouldn't matter, right? We're looking at how far I actually displaced. So let's say I had like a little man, right? A little man, and the little man or woman is going to be represented by this little circle here. Okay? So if I started at point A and were to take one trip across, my distance would be 100 meters. My displacement would also be 100 meters. I come back halfway, now it's 100 plus 50. My distance would be 150. Would be my distance. But my displacement now, displacement is actually the symbol S, and I'll explain why in a minute. But since I'm only 50 meters away from where I actually started, my displacement would only be 50 meters. It's kind of crazy, right? And 50 meters to the southeast, 50 meters southeast, so we care about the direction. Okay. So let's look here, let's practice. The person walked from point A to point B on this rectangle. What is the total distance? Remember, distance is scalar, right? Okay, so let's see. So point A, and we're going to assume they walk downward, okay? We're going to walk downward. A to point, D, so down A, so that's 4 meters, and then we're going to go to point D, right? So one more, let's get another arrow open here. All right, so let's count these up. 4 plus 8 plus 4, so make sure to show your work. 4 meters plus 8 meters plus another 4 meters, and that's going to be what? 16 meters is my total distance. And we don't need to have a direction because it's a scalar quantity, right? Now we're looking at the displacement. We're looking at the straight line, right? Straight line. So how would I get from A to D in a straight line without having to make any turns? Boom, just like that. So my displacement would just be the simple straight line path from A to D. That's going to be 8 meters. And 8 meters what? To the east, right? 8 meters east. Or you could say 8 meters to the right. Okay, either way is fine. And what if they walk from point A straight to point C? Okay, so the distance would be A to C, 4 meters plus 8 meters. That equals 12 meters. My displacement, though, is kind of weird. We are going to go straight from A to C, just like that. So A to C. So what type of shape do we have here? We have ourselves a weird little nifty triangle, right? So we know that when we're doing displacement of a triangle, look at this. You might have known this from geometry, or maybe you're studying this right now, but the triangle can be written as A, sides are A, B, and C is always going to be the hypotenuse, right? So remember this nifty little theorem right here, the Pythagorean theorem. This Pythagorean theorem right here. So A squared plus B squared equals C squared. So we just plug in our values. So what's our A? A is equal to 4. B is equal to 8. So we'll just go ahead and just plug them in right here. 4 squared plus 8 squared equals our C squared. How do you get rid of a square? What's the opposite of squaring something? I'm going to go ahead and tell you. The opposite of squaring something, I'm going to go ahead and make this red, is a square root. So it's like this radical, right? And whatever I do to one side in algebra, I have to do to the other side. Okay, so you can just put this in your calculator, and you get 8.9 meters. And we have to look at the direction. So remember, never eat sour watermelon. And we went southeast, right? So that's our direction, southeast. Okay, I'm going to do just a couple quick examples real quick. Like, how would we figure this out? So let's say I traveled, again, southeast. So how would I get, what would be the distance? The distance would be 4 plus 3, 7 meters. But the displacement would be the square root of these, right? So A squared plus B squared plus C squared. Plug them in. 4 squared plus 3 squared plus C squared. And how do I get rid of the square? Remember, square root, both sides. So that will end up being 5. Let's see. 5 meters would be my displacement, right? And over here, same thing. A, B, C. 12 squared plus 5 squared equals C squared. Let's do the square root of that. Whatever I do to one side, do to the other. And that ends up coming out to, if you put in your calculator correctly, 13 meters. Okay, so that would be my displacement. Even though my distance, this is southeast, right? Southeast. And my distance would be 12 plus 5, which is 17 meters. All right. Good luck with that.